All right, so now we are doing a thing called the Incenter. Now, on the lesson plans, I said Incenter and centroid, and I was supposed to teach it tomorrow. But I'm just going to split it up, okay? I thought if I try to do both of them in one class period, I thought it would be too crammed, all right? So this might take most of the class period anyway. All right, enough said. So what we're going to talk about, I'm going to use that GeoGebra program for the vast majority of this, but I just want to show you something. Here's a word that I don't know if we've talked about. Here's an angle, right? I won't put the arrows on there. But what if I said I wanted to bisect the angle? Did we talk about that? I think we might have talked about that before. But that, you should know what that means, though. If I say bisect the angle, what does that mean I'm going to do to this angle? Do what? Just do that? Put a line where? Where's the midpoint? Put the midpoint of this? Remember, this is an angle, so that's a ray. So do these rays have midpoints? No. So I'm going to draw another ray. Let's put this in a different color. If it'll click. Come on, click. There we go. So what am I going to do with this ray? Where am I going to put it? Let's say that angle is 60 degrees. If that angle is 60 degrees, where am I going to put this ray? Will that bisect it? Right there. Does that look like it's bisecting it? What do you think it means to bisect it? Split it into what? In half, okay? Into two equal parts. Bi, right? B-I, that's the prefix for two, right? We're going to sect it or intersect it, right? So bisect means we're going to split it into two equal angles, okay? Is that being bisected? No. Okay, so it's not just any ray anywhere. It's got to specifically cut that in half. Where do you think it looks like it cuts it in half? About right there. It's pretty close, isn't it? All right, so if this angle right here was equal to this angle right here, then what's true about that yellow ray? What does it do? It does what? It bisects it, okay? So we could also call it an angle bisector, all right? So this ray, this yellow one right here, is called an angle bisector. Why? Because it bisects the angle. It splits the angle into two equal angles. Everybody with me on that? All right, so that's important. Now let's do this. Let's jump over to the GeoGebra program, and let me click on that, click on that. There we go. All right, so now what we're going to do, now watch this. I'm just going to show you. Now on that program I just used, I could kind of like guess where the bisector was, but this one will tell me exactly where the bisector is. All right, so that's kind of nice. All right, so, oops, I don't want that. Yeah, so let's do this. I'm just going to draw an angle, and then there's an angle. Any old angle, whatever, just made it up. Oops. There we go. That's what I want. Okay, so now what I want to do is I want to bisect this angle. So I could take this other segment and just kind of guess where it should be, but is that really what this program is for? No, this program is to be specific, right, and to exactly bisect it. In fact, I have an angle bisector thing right there. Do you see it? It says angle bisector. So watch. I click this. I come over here. I click this side. I click this side. And boom, it makes a bisector. Now, it gives you this, which is perpendicular to the bisector. Not really sure why they do that. I was thinking last night about why they do that, but I've got a way to get rid of it. If I go over here, see how it's highlighted? I click it, and it goes away. And here I'm going to do something else just to make it look a little prettier, because this is a line, right? This is a line that bisects the angle, so it keeps on going. Watch, I can make this smaller, smaller, smaller. It'll never, ever, ever end, all right? So let's make it bigger again. All right, so what I want to do is this. I'm going to put another point right here. I'm going to take a segment, and I'm going to connect it from A to D. All right, and then I'm going to click on this. I'm going to get rid of that. See, I'm getting a lot better at this now. There we go. So there's my angle bisector. Since I specifically made it a bisector, I could take this. Look, I'm trying to move this up and down, but it won't budge. Why? Because this is the halfway point. Everybody see it? So this is where it's half of the angle. So I can move it in and out, but I can't move it up and down. I'm trying, but it won't go up and down because it's specifically an angle bisector, which is kind of cool. All right, what if I wanted, now it looks like it splits that angle into two equal angles. Remember yesterday, I could actually find out what that angle is. So if I, actually, let's use the mouse pad instead. So watch, if I see it says measure, so I'm going to measure the angle. So I click that, so I can click this side, and boom, it gives me an angle. Let's push it out a little bit. So that angle is 27.3 degrees. So if this is truly an angle bisector, what would this angle right here be? 27.3 degrees, all right? So let's do it again. So we're going to measure this angle and this angle, all right, and pull that out. Yep, sure enough. And the coolest thing about this program, or one of the cool things about the program, is I could change this angle. Watch. See that? I'm changing that original angle, and it still, look, no matter where I stop, those two angles are going to be equal to each other. Why? Because AD is a what? Angle bisector. That's the key, all right? Now, we're going to deal with a triangle here in a second, all right? So it's really important, though, to understand this. Do you remember we did the circumcenter? What did we know about the circumcenter? What did we do to that triangle? What did we learn first before we found out where the circumcenter was? No, that wasn't the altitude. It was the perpendicular bisector, right? So we had to learn about perpendicular bisector first, right? Then we applied it to the triangle. Then we did orthocenter. Now, tell me, what did we find to get to orthocenter? The altitude, right? So we had to learn about altitude, right? Okay, and then we applied it to the triangle. So now, what are we doing now? We're doing angle what? Angle bisector, and so we're going to take that and we're going to apply it to our triangle. And what was the title of this lesson, by the way? It was Incenter. So how do we find the incenter? What are we going to do to the triangle? Find the angle bisectors of all three angles, exactly. All right, so I'm going to make a triangle. Just make any random triangle. Doesn't matter. Okay. Let's just take this out a little bit, make this a little bit bigger. Okay, that's good enough. This is an acute triangle, but it doesn't have to be an acute triangle. We'll see a little bit later. We'll do the angle bisector thing, and we're going to find the incenter. Now, remember the orthocenter? There was really nothing really special about the orthocenter, okay? There was definitely something special about the circumcenter. Do you remember that? What did the circumcenter do? What was special about the circumcenter? Okay, yeah, it made a circle around the triangle, okay, but there were some certain lengths that were equal to each other. Do you remember that? From the circumcenter to where? To the vertices, to all three vertices. Remember that? Okay, so look back on it if you don't remember. Now, these are hard to keep straight, even for myself, okay? I have to think about it. I got to study it before I even come in here because, you know, if you would have asked me the first day if I didn't study this stuff, I really would not have remembered it from last year. Like the circumcenter is the perpendicular bisector. I probably wouldn't have remembered it, okay? So this is something you got to keep on all the time. Every night, look at your notes, review. How do you find the circumcenter and what's special about the circumcenter, okay? What's special? Well, it's equidistant from the three vertices, okay? How did you find the orthocenter? That's the altitude. Well, there's really nothing special about the orthocenter, though. Okay, now the incenter is the next one we're going to do. So there, how do you find the incenter? Find the angle bisectors, okay? And we're going to look in a second what's special about that incenter, all right? And there is something special about it. But let's do this first. Let's find the angle bisector. So I'm going to come over here. I'm going to hit angle bisector. And then I'm going to bisect this angle right here. So I click this and I click this. And there's my angle bisector. See that perpendicular line right there? I'll get rid of it in a minute. So what I'm going to do right now is just find the angle bisectors. Then I'm just going to clean it up a little bit so you don't have lines flying all over the place and make it look a little nicer. All right, so now let's find the angle bisector of this angle. There it is right there. See that line? Now the intersect here, take a wild guess. When I make the angle bisector right here, where do you think the bisector is going to meet? Right there where these other 2 points. They're going to be concurrent, okay? So every one of these things that we're going to do, they're concurrent lines. Okay, the orthocenter, they meet at one point. The circumcenter, they meet at one point. The incenter, they all meet at one point. Okay, and then the next one we do, guess what the next one is? What do we call it? Centroid. What do you think is going to happen to that? However you get the centroid, they all meet at one point. Okay, so every one of these things meets at one point. All right, so let's see if this one does as well. So click here, and there you go. So there's that point right there is the what? What's the title of this lesson? It's the incenter. That point right there is the incenter. Okay, but that's how did we get the incenter? We bisected all three of those angles. That's how we got the incenter. Everybody good? All right, give me just a minute. I'm going to get rid of a lot of these things. So I got to go to this algebra. Let's find out where that is. So I'm going to get rid of that line. I'm just doing this just to make it a little prettier so you don't have things flying all over the place. Get rid of this. All right. Now what I want to do, I don't want those lines extending out beyond the triangle just because it looks a little sloppy. So what I'm going to do is this. I'm going to put a point. Actually, I didn't. Right there. Okay. That's the incenter right there. And then I'm going to put, actually, let's do this. Let's just get rid of all the lines and just keep the incenter point there. All right. So everybody understand how to find the incenter? You bisect the angles. All right. So now what I'm going to do is I'm going to get rid of all those other lines. So let's get rid of this line right there. Let's get rid of this one. That's right there. And let's get rid of this one. And that's right there. All right. So that point right there is the incenter. And let's change. We'll put the name, instead of calling it H, let's call it incenter, just so we remember. All right, so there you go. That's the incenter. It's a different place than what the circumcenter would be, and it's a different spot than the orthocenter would be. All right, so but this is the incenter. If I move this around, right, the incenter is still where the angle bisectors would meet each other. Okay, no matter how I move it around, that's where the incenter is going to be. All right, now what is special about this incenter? Well, I'm glad you asked, because that's what we're going to talk about. All right, so what is special about that incenter? Well, I'll just tell you what it is, okay, instead of having you guess. The incenter, now listen to this verbiage, okay, how I say this. It's equidistant from the three sides of the triangle. Hear what I just said? The incenter is equidistant, not from the vertices. It's from the sides of the triangle. So we have to talk about something here. Well, I think I can fit this in here. Let's talk about this. What is the distance from a point, put a point right there, to a segment right there? Okay? So if I ask you to measure the distance from point H to line segment IJ, how would you measure it? That's right. You would measure it perpendicular to this line segment. Everybody hear me? That's the same thing as altitude, isn't it? Okay, but that's the distance. So when I say, what is the distance from the incenter to EF? What would it be? It would be from here, where? Would it be to there? Would it be to there? Would it be to there? Where would it be? Perpendicular to it, okay? That's really important to understand. I'm going to get rid of that because I've got a thing on here that says I can make a perpendicular line. All right, let's just do it right here. So what if I wanted to go from point H to IJ? I would have a perpendicular. Here's perpendicular line. So I'm going to click that point and this line. There's your perpendicular line right there. Everybody see that? I could, get rid of the whole length. I mean, it's a line because it keeps on going forever. I'm just not going to do that because I'm going to have to do that. Oops. Okay. Always forget. I got to hit escape to get out of all that. All right. So now what we're going to do is we're going to go from the incenter, and what are we going to do? We're going to make a line that's perpendicular to all three of these sides. And what did I say is true about it? It's equidistant, right? So all three of those distances, from the incenter to this side, from the incenter to this one, from the incenter to this side right here, they're all going to be the same distance. Okay? Now, I could have just drawn it down and say, okay, just believe me. But the thing I like about this program, it kind of proves what I'm saying. All right? So what we're going to do is we're going to do perpendicular line. Again, it's going to get a little messy, then I'll clean it up. So I'm going to go from the incenter. I'm going to go perpendicular to this line. So I click it, boom, there it is. See, it's perpendicular to that line. Everybody got it? So I'm going to do the same thing to the other stuff. I'm going to go from the incenter to here. That's perpendicular. See how it makes that right angle? Then I'm going to go from the incenter to here, and there you go. Check it out. Well, don't check it out. It all came from the Incenter. We already talked about they all meet at the same place. So what I want to do, I just want to get a little segment from the Incenter to this point right here. So what I'm going to do is I'm going to put a point right where it intersects, right there. I'm going to put a point right there, put a point right here. And then I'm going to get rid of this line. Where is it? Right there. I'm going to get rid of this big old line right there. Tell you what, I'm getting a lot better at this than I was before. There we go. And to tell you the truth, no, let's keep those there because those are important. All right, so now what I'm going to do is draw a little segment from the Incenter to where it's perpendicular. You see that? So would you agree that that's perpendicular now? Because I had that perpendicular line before, I put the point there where it intersects, got rid of the big line, just made a little tiny line segment. And what should be true about all three of these line segments? They should be equal to each other, equidistant, correct? All right, they should be equidistant from each other. Do I have a way on this program to find out if they're equidistant? Sure. I could measure the what? The length or the distance of those right there. So I can just click on this. That's 4, so what should this be? 4, and what should this be? 4. There you go. And it works, doesn't it? Does it only work because I made that triangle like a particular type of triangle? No. Okay, so if I take this triangle, I can make it any shape, right? So that's obtuse, right? Look at the lengths. 3, 3, and 3, right? I could do like that. 2.3. Make them 2. Make them. There you go. They're all 2. All right. It doesn't matter what the shape is. I could have made it into a right triangle. It doesn't matter. I could make it obtuse. I could make it right. I could make it acute. What's happening to that Incenter? It's the same distance to all 3 sides. Everybody got it? Do you see where this could be confusing, though, to remember every one of these? Okay. Now let's go back. Let's review a little bit. Circumcenter. The circumcenter is the same distance or equidistant to what? To the vertices. Okay. The orthocenter is nothing special about it. Okay. The incenter is the same distance to the sides. Okay. And what is the distance from a point to a side? It's the perpendicular. It's the altitude, right? It's the perpendicular distance. Okay. So that's really only 2 things so far that we got to remember. Agreed? All right. As far as, what's special or what's unique about, all of those. So that's kind of cool. Remember we did the circumcenter and we had the circle that went around, right? Because the distance to the vertices was the radius of that circle. Remember that? We're going to do something a little, and why did we call it circumcenter? The whole reason I did that because I wanted you to see why they called it circumcenter. So circum means what? The circumference of the circle, the outside of the circle, right? So it goes outside of the triangle. This is incenter, not outside, but what? Inside. So where do you think the triangle is going to be here? It's going to be inside the circle. So watch this. It was outside the circle before. No, I'm sorry. The circle, did I say it wrong? Let me try to say it again. Make sure I say it right. On the circumcenter, the circle was outside the triangle. So the triangle was inside of the circle. Okay? This one, the circle is going to be what? Inside of the triangle. I may have misspoke. I don't remember what I said. Okay. You can look back on the video and see if I did or not. But that's what it is. Okay, so what we're going to do is we're going to come down here to the circle thingy. It says circle with a center, so I click on that button. So all I got to do is click on that point right there. That's the center. Extend this out. And check this out. Boom. It snaps right into place. It is crazy. See, look, all 3 of these distances are the same. So all 3 of those distances are the what of the circle? The radius of the circle. Okay? But on the other one, the circumcenter, it was from the circumcenter to the vertices, right? So the circle went outside of the triangle. This time, it's in the triangle, in center. Make sense? Circumcenter, circle's outside. In center, the circle's inside. Or we use a word called circumscribed. All right, I think I might have mentioned that yesterday. Circumscribed. So we say, we say the circle is circumscribed inside the triangle. Okay? So I just think that's kind of cool that it just snaps perfectly. Look, the edges are exactly the same. And it should make sense, right? Because if you have a point and you have the same distance coming out of that point, you should be able to make a circle out of it. Agreed? Yeah. So now, if this was not 3.6, if it was 4 or something like that, you couldn't make a circle out of it. All right? So, but if they're all the same, they got to be the radius of the circle. And that means the circle is inside of here. Now watch, I can mess around with this and move it all around, and that circle never comes outside of that triangle. See that? You can make it like this. You can make it like this. You can change one of the other ones. All right? Doesn't make any difference. I don't know if you can, yeah, see, this one just extends it out and in a little bit. All right? And all those stay the same. That circle stays right inside there, which is kind of cool. I think that's all there is to the Incenter. It's a pretty cool program, isn't it? Yeah, I think it's neat. I mean, I could have just written it on that Blackboard thing, on the regular thing that I do, and just say, okay, this is all true. And that's what I used to do for years until I stumbled across this. And I thought, this kind of explains it so much better. You can move stuff around. I think it's pretty cool. All right, so what are you guys working on today? You're doing the section B, right, of yesterday's lesson. So you're doing 18 to 28. Maybe we can go over 1 to 7. Do you have questions on 1 to 7? Was it pretty simple? Okay. I think on 18 to 28, you're actually going to do some numbers and do some actual math. Because on 1 through 7, you didn't do really any math, did you?
Are we doing it on the same paper?
Let's do them separate. All right, I'll give you 2. You get 10 points instead of 5. That's better, isn't it? Yep. Okay, that's all I got for today. Just work. Yeah, that's the 18 to 28 is due tomorrow. I'll collect 1 to 7 right now if you want.